Hello, today I am going to discuss about the PLC input interlocking as well as output interlocking in the PLC ladder logic programming. Okay, so let me create a new file. Let me close this file and open the new file. Okay, make sure the driver is emulated 500. Click OK. So let me create a few new rungs. Okay, maybe I make it bigger. Okay, I insert the virtual switch here as well as a virtual output coil here, right? Okay, let's say I give an address. This is a digital input column slot 0 switch 0. Okay, description I put switch 0, right? And then this one digital output column slot 0 switch bit 0. So this one I'll name it maybe pump 0. Okay, so I will copy the instruction to here and same for this. So I will change the bit to 1. Description I put switch 1. Then this one I will change the bit to 1. So description I will say pump 1. Okay, so in a normal PLC programming, if I set this from trigger this switch virtual switch from normally open to close, the virtual power will run and energize this output coil, the virtual output coil, and thus will then turn on the pump 0. Okay, this is simple. So now we are talking about the interlocking. As we know, there are two types of interlocking: input interlocking and output interlocking. Input interlocking is the interlocking involve the use of input address, whereas for the output interlocking is the interlocking where it involve the use of output address. So what I mean by this, let me show you. Okay, let's say I drag this virtual normally close instruction and then one more to here. Okay, then I will copy this address from here to here and I do the same for this one to here. So if you observe carefully, this switch 1 and switch 1 having the same address, and this switch 0 and this switch 0 of course having the same address. That means they are interlinked one another. Okay, the only difference is they are normally closed switches. All right, so what happened is if I simulate switch 0, which is an external normally open switch 0. Okay, if I simulate to turn on the external physical switch 0 from normally open to close, the current will flow to the PLC digital input terminal point 0 to energize its internal LED. Thus, it will trigger the virtual switch, which is this one, from normally open to close, and the virtual power will flow through this circuit to turn on the pump 0. Okay, and because of this, it will at the same time trigger this virtual switch from normally close to open, thus preventing any virtual power to energize this virtual output coil 1. Thus, it will not turn on the pump 1. So this is the purpose of interlocking. Meaning this interlocking purpose is to only allow one pump to run instead of two pump or another pump to run. So if I turn on this switch, I expect this pump to run, not the other pump. If I turn on this switch, I expect this pump 1 to run instead of pump 0, or both pump to run. Okay, so let me verify it to ensure there's no error, and then I will save it. Okay, save it into my computer hard disk. Okay, maybe I name it as interlocking. Alright, then I will click here to download to my virtual PLC, which is this one, emulate 500. Okay, then I click to select run. Okay, so when I trigger this to close to simulate the external physical switch 0 being pushed to on, okay, this will be triggered to close, and the virtual power will then flow through this run to energize this virtual coil output 0. Thus will turn on the pump 0, which is the external pump, right? And because of this, at the same time, this and this share the same address. It will be triggered from normally close to open, thus preventing the virtual power to energize the virtual output coil 1, and this will prevent the pump 1 from running. This is our purpose of interlocking. Okay, let me demonstrate. Let's say I click the toggle bit. This is turned on. At the same time, it will trigger this virtual switch from normally closed to open, thus preventing pump 1 to run. This is our purpose. Okay, let's say I turn on this one. What happened? This pump 1 is turned on and pump 0 is off, because this when trigger from normally open to close. At the same time, this virtual switch will trigger from normally close to open, because both share the same address. Okay, so what is output interlocking? So output interlocking is an interlocking involve the use of the output address. So I can click this address and pull it to here, so that I will be copy over. So pull this address, okay, by clicking this black highlight and then drag to here. So the address from here is copied to here, and this output address is copied to this virtual switch here. So this is called output interlocking. Okay, so let me download again and then click the run. Okay, now if I trigger this to close, what happened? Only pump 0 is run, and this will prevent pump 1 from running. Alright, okay, then if I click this one and then select the toggle bit, this virtual switch will be triggered from normally open to close. At the same time, this virtual switch will be triggered from normally closed to open, thus preventing virtual power to flow through this run to turn on the pump 0. And only the pump 1 will be turned on. So this is the purpose of interlocking. Okay, that's all. Thank you.